Hello again, guys. We are here for 10-6 reasoning in algebra and geometry, and this is actually one of the things that I learned back when I was a kid. I was really big into magic, and if you can memorize this will impress people to no end, because go ahead and try this on your own and then try to explain how this works. We're actually going to go over this more in class if you guys are interested, but I'm not going to take time in the video to go through it. But check this out and just analyze why does what happens happen. So our key concepts here for this lesson are some properties of equality that hopefully some of these are familiar, some of them might be new, but we have our addition property, which is just essentially telling us that if we add something on both sides, we stay equal. Same with subtraction, same with multiplication, and same with division. But these properties are probably maybe new for you. We see the reflexive property is something is equal to itself. So like 5 is equal to 5. It just makes sense. A symmetric property is if one value is equal to another value, then in the reverse order, that other value is also equal to the original value. And our transitive property is just like our law of syllogism that we just used. If A is equal to B and B is equal to C, then A must also be equal to C. And likewise, we can substitute in if A and B are equal, then I could replace B for A or A for B, and it would not make a difference. Our distributive property is just telling us that if we distribute on one side, or if we distribute a term into the parentheses and then get a new like binomial term, this will be the same as the original expression that had the parentheses involved in it. So now we're going to work our way into writing geometric proofs. And a geometric proof is where you have to justify and give reason for every step that you've done. So here you can see are the steps that we've taken to solve this problem. And really now you're going to be given the solution to a problem, and you're just going to be asked why were things done. So we're asked what is the value of x and justify each step. So we know that AOM and MOC are supplementary, which again, supplementary means that they share a point and add up to 180 degrees. They don't necessarily have to share a point, but in this situation they do, our point O right there. So we can say that the two angles add up to 180. We can replace for the angles. We can then combine our like terms, and then we start to solve using the methods that we know. So really that's all you have to say. We just say that the definition of supplementary angles are that they can add up to equal 180. Likewise, we just substituted in the values that we have in our angles to replace the angle names. Then we just use our distributive property. Actually, this should not really be distributive property. It should be combining like terms or something written like that. We did not distribute a multiplication, so I would actually say that that is not a good justification for this step. Then we use our subtraction property because we subtracted 30 from each side. And then we use our division property of equality. So I'm going to pause the video really quick. So for the got it, start by just writing out the steps of solving for y. So on the left of your paper, go ahead and write out how it is that you're going to solve for the x value. Sorry, I think I said y before. And then we'll write out the reasoning. So just write out your step-by-step solution, then we'll write your reasoning. So because I know that an angle bisector makes two things equal, I now know that this angle x is equal to this angle 2x minus 75. So I can set up the equation right here. Because I always want to combine like terms, I can bring my 75 over to the left just to make it positive. And then I can bring my x over to the right by subtracting it to set that to isolate the variable, and then I just find that x is 75. So now I need to justify those steps to actually write my proof. So when I write my initial equation, you ask yourself, how was I able to write that equation? And the only reason you're able to is because that was an angle bisector. So an angle bisector makes x equal to 2x minus 75. So you always have to list the reason of how you started. Then to get to my next step, so this definition right here, this reason is going to be how we got from step 1 to step 2. And we did that through the addition property of equality. We added 75 to both sides. Then when I remove x from both sides, that is just my subtraction property of equality, and then we're done. So that is the beginnings of how we make a proof. All right, so here's the extra practice on your paper. So I want you to go through step by step and just try to list the reasoning for what happens. Now, if you are just given an equation to start and it just says solve for x or just tells you what to do, unlike our situation here where we had the angle bisector, all we have to do is state that this was given. My equation was given to me. So this is always a good first reason. If the equation was given to you, it's just given. So then do your reasons for A, B, and C here. So again, to find our reasoning, we have to ask ourselves, how did I get from step 1 to step 2? That is going to be my second reason, is how I got to step 2. So how did I get here? Easy thing to do is look at the side that only has the constant. What happened? We multiplied by 2. Same thing over here, we did this multiplication by 2. So I can tell myself all I did was multiply by 2. So that property, the reasoning behind that, is the multiplication property of equality. Same thing between steps 2 and steps 3. What happened? Well, the 2 distributed into the parentheses, so all we did was a distribution, and that means that the reason behind it is the distributive property. And then between this step, my third step, and my fourth step, what did I do to isolate the x? All I did was add 10. So that property that allows me to do that is the addition property of equality. Go ahead and try number 2 to list out all of those reasons. You just have to keep asking yourself, how did I get from this step to the next step, to the next step, to the next step? That tells you all your reasons. Our first step here might be something that you've never seen before, so I figured it's worth talking about. We're told, our given is that the segment xy, over here, xy, is equal to 42. So we know that from x to y is 42, but we don't know what x to z is or what z to y is, but we know that it takes xz and zy to make xy. So we call this step right here the segment addition postulate, which is just saying that the segment xy is created by adding the segments xz and the segment zy. So then keep moving on down your steps from there. All right, we got a little bit of Worthington colors going on here for my screen shields. So we have our segment addition postulate that starts us off. Then we see that xz over here, we're told, is 3 times n plus 4. So we replace that there. Zy is 3n. So since all we did was replace in values, another word for replacement is substitution. So that we just call our substitution property. Then, because I take my 3 into the parentheses and do that multiplication, what do we call the multiplication into parentheses? That's right, we call it the distributive property. Then I did some digging about this, and because here all we're really doing is combining my like terms, this 3n and this 3n, in order to get that 6n, you can either call it, you can actually call it the distributive property, that is allowed, or you can call it the commutative property of addition, because all I do is move things around and then add like terms, or you can call it addition of like terms. I mean, there's always, not always, but there are often multiple different ways that you can phrase what's going on, especially in a situation just like this. Now, distributive property, that's kind of cut and dry. It's the distributive property. But here, there's a few different reasons we could put in. Then we ask ourselves to go from this step to my next step. How do I get rid of that 12? Well, we got rid of it on both sides. So that's our subtraction property of equality. And then to finish us off, the last thing we do is the division property of equality. So if you are strong at solving your equations, most of this should be straightforward, just writing down what in your head you're thinking you need to do. All right, again, we have another key concept here, so make sure that you're paying attention to click on that in the Pearson lessons. So we have our reflexive, symmetric, and transitive properties, all about congruence and segments. So here, remember, anytime we have 2 letters with a little bar over top of them, that is talking about a line segment. So we know that if AB is congruent to AB, then angle A would be congruent to angle A. Go ahead, read through these, make sure they make sense. Pause the video if you need to, because I'm going to move on to problem 2. So we here are going to use our properties of equality and congruence. So take a second to analyze what we should do here. So this is like a drill in figuring out how you go from one step to the next and what the justification behind that is. So to go from the 2x plus 9 equals 19 to just 2x equal to just 10, what happened on both sides? Well, there was a subtraction. We subtracted the 9 from both of those. If I see that angle O is congruent to angle W and angle W is congruent to angle L, that is like our law that we were using in the last lesson. So we can go straight to saying that angle O is congruent to angle L. So that would be our transitive property. Remember, if we're like transferring A to B, B to C, then A can go to C. And if angle E is congruent to angle T, and the measure of angle T is congruent to the measure of angle E, well, that's just saying the same thing over again, but backwards. So it's the symmetric property of equality. For our got it here, pause the video and figure out the reasoning, how we go from each step to the next step, what property of equality or congruence lets us justify this for A, B, and C, and then we'll come back to talk about D. So pause the video and try this on your own. Alright, so when we look at a segment being congruent to another segment, and then we turn it around and say that that other segment is congruent to the first segment, we can say that that is just the symmetric property of congruence. We see that they are both congruent to each other, which that will always hold true no matter what order we put them in. Then I look down here at B and see that 3 times x plus 5 equals 9, and then we see 3x plus 15 equals 9. That, all we did was distribute. And I went ahead and dragged the other one, it blocked this together somehow. What we see here is the multiplication property of equality, which actually, anytime we have multiplication property of equality, division property of equality could also work because you can always multiply or divide, but here, easiest thing to do would have been to multiply by 4 on both sides. So then down here for D, what property justifies the statement that the measure of angle R is equal to the measure of angle R? And when something is equal to itself, think about when you look in the mirror. You see yourself. You are equal to yourself. So think about a reflection, but it's not reflection, it's reflexive. It's the reflexive property of equality. Go ahead and try your extra practice, 3 and 4 right here. Figure out the reasoning for both of those. So in 3, we have a segment congruent to another segment, and we make that same statement again, just in the opposite order. So just like up in the got it, you should realize that that is symmetric property of congruence. And then, and by the way, you don't have to write congruence, you can just use the symbol, so you could just write symmetric property of and then put the symbol. So over here in 4, we see that we have AB minus BC is equal to 12, and then AB is now alone equal to 12 plus BC. What change happened? There was an addition on both sides. That makes it the addition property of equality. So now I'm running out of time, so I'm going to move quickly, but we're talking about proofs now. So read what a proof is, pause the video to do that, and then make sure that all of this makes sense. What you're setting out to prove is what comes last. What you're given to begin with is always what comes first. We label that given. Our reasons always justify our statements, and like reason 2 would be how we got to statement 2. Reason 3 is how we got from statement 2 to statement 3. So in problem 3, we set out to write a 2-column proof to justify how we know that angle AEC is equal to angle DEB. What we know is that angle 1 is equal to angle 3. So analyze our drawing here. We've got angle 1 and angle 3. And these guys are equal, and then we've got angle 2 in here all by itself. So what we could do, since we're looking at AEC, well, AEC is the combined angle 1 and 2, DEB is the combined angle 3 and 2, so let's look at the proof down here. Here's all the steps. If you couldn't think up the steps on your own, see if you can think up the reasons on your own. So we know angle 1 is equal to angle 3 because that's given. Angle 2 is equal to itself. Again, that's reflexive. Think about a mirror and reflective. Then I can use my given statement and add angle 2 to both of them. All I need to do for that is use the addition property of equality. Then I can say angle 1 plus 2 equals my larger angle AEC. Same thing with 3 and 2 equaling DEB. All that is our angle addition postulate, just like our segment addition postulate. And to finish us off, we will now be able to say that AEC is equal to DEB because of the substitution property. We know that 1 and 2 were equal to 3 and 2. 1 and 2 is AEC, 3 and 2 is DEB, so now I can plug in AEC to the left, DEB to the right, and we've got our final. So for the got it, pause the video and try this on your own. You want to prove that AC is equal to BD, so you're trying to prove that this segment here, AC, is equal to this segment here, BD, and this is going to work extremely similar to the angle problem that we just had. So pause this, write the whole thing out, come back. I'm only going to show you the answer because we're running out of time. If you didn't pause the video yet, do it now. Here's your answer. So we know that AB is congruent to CD, that's given. We know that congruent segments have equal length, so we can just say that they are equal to each other. You can read the rest of this Please make sure that you have worked through the entire Pearson module. There's a couple other things on the notes to work through. Let me know if you have any questions, comments, or concerns, and have a great day.